All right, so this first problem that we're doing here today, it's a proportion that involves cosine. So the first thing we're going to be doing here is, well, what? What do we do when we're going to solve a proportion like this? We, cross multiply. So in order to actually solve this, we have to start by cross multiplying, which means we're going to do a times 1. Well, that part's fairly easy and straightforward. But then we're going to do the 10 times cosine of 60. Now, when we do this 10 times cosine of 60 over here, we cannot just multiply the 10 by the 60, because the 60 is inside of the cosine. The 10 is not. It's just a number out there. So we have to treat them as separate. In terms of order of operations, when we go and do this, we got to do the cosine before we do the multiplication. Now in this case, it works out all kinds of pretty. Now, before we do that calculation, make sure that your calculator is set into degrees. This is what I want you to be able to use to check that. Do sine of 30, make sure it gives you 0.5. You should memorize that as a value because it comes up so often. If you're doing a test or a quiz and you're having to do cosine or sine or something like that on it, the first thing you should do is make sure your calculator is in degrees, or every problem is going to be wrong on it. And so start by checking sine of 30 equals 0.5. Once you've done that, then we can go ahead and do the cosine of 60. And when we do cosine of 60, you should be finding here that it is also 0.5. And then to get our final answer, we're going to do 10 times 0.5. So we end up getting an answer of 5 here. Here's your next problem. It's set up very similar, but some of the work is going to look a little different. So write it down and start working through it. So again, I'm going to start the same way. I'm going to start by cross multiplying. So I'm going to do the 1 times 14. Of course, that's going to be 14. But then I'm going to have to do b times sine 77. Now, when we do b times sine 77, that just leaves us with b times sine of 77. There's not really anything else I can do to that. Now, in the last problem, after I cross multiplied, it was nice and smooth. All I had to do is the calculation. In this case, I got to do some extra steps. So in this problem, I still want to get the b to be by itself. Notice that means I got to get rid of this times sine of 77. Okay, so I currently have b times something. If I want to get the b by itself, I want to divide by that something. So that means dividing by sine of 77. Now, I'm leaving it written as sine 77 here rather than writing it as a decimal, just because I'm going to go ahead and do all the calculation at once. You could actually write the decimal here, but you're going to have to remember to use the whole decimal when you do the final calculation. So I do find it a little bit easier to just write it this way for now. When we do that division, on the left side, the whole idea of dividing by sine of 77 is it makes that sine 77 go away. On the right side then, we know we're doing 14 divided by sine of 77. Now we can do the calculation, because now we have what b equals. And b equals just something involving numbers that I can calculate. So now you break out the calculator and you do this calculation. So you're going to do 14 divided by sine of 77 equals, and you should get your answer. Now to make sure that you can get the right number out, do the calculation, but make sure you're getting this number, about 14.37. So we just looked at how to solve some equations that involve trigonometry. We're now going to be going to the next step where we're going to have to write those equations and then solve them. Now writing those equations though means you have to know this information. If you do not already know this by heart or have written it down already, you need to be writing it down right now. This needs to be part of your notes if you don't already have it memorized. Now some of you already got it memorized from geometry, that's fine. But even there, if you want to have it as a hint, maybe write it down. But you need to have this written down, including not only all of these definitions over here, but also the picture that goes with that. Because one without the other is not very helpful when you're first learning how to do these. All right, going forward now, I would expect that any time you need to know what sine, cosine, or tangent equals, you're going to be able to tell me. And oftentimes that'll be in terms of the definition. So I might say, what's the definition of sine? By that, I mean the definition of sine is opposite over hypotenuse. Because these are really what these functions are defined to be. All right. Now, once we know that, yeah, you're going to have it in your notes. But if you forget, like you're on a test and you can't use your notes, if you forget, what's that thing that you remember?
Sohcahtoa.
Yeah. Sohcahtoa. You might make note of this as well if you didn't remember what Sohcahtoa was, at least how it's spelled. Because this lets us remember what sine, cosine, and tangent all equal. Because the S, it stands for sine. And sine equals opposite over hypotenuse. And so you can actually see in here that it tells us what sine equals. Next up is the C. Okay, C's got to be cosine, right? And you notice it goes C-A-H. A-H, A must stand for adjacent. H still stands for hypotenuse. So cosine is adjacent over hypotenuse. And then the T, that's tangent. So tangent equals opposite over adjacent. So by remembering Sohcahtoa, you can help yourself to remember what does sine, cosine, and tangent all equal. Now that we know what sine, cosine, and tangent all equal, got to go back one critical little piece that I just want to remind you of. What type of triangle? What type of triangle do we have to start with in order to be able to use sine, cosine, and tangent?
Right.
Yeah, in order to be able to actually use sine, cosine, and tangent, it's got to be a right triangle. That just means it's got a 90-degree angle in it. So all these other times when you're going to see sine, cosine, and tangent come up, it's always a matter of starting yourself with that right triangle. And you notice how it's shown here. Remember, a right angle, that is a 90-degree angle, is shown by putting that little square in that corner. All right, now let's practice naming each of those parts. So, in this picture, first up, a little bit about naming conventions. You would have seen this in geometry, but you know, geometry was a while ago. It can get rusty, so let's remind ourselves. Capital letters and lowercase letters always have to represent different things. What do capital letters always represent? Angles, yeah. So notice like capital A there. That represents angle A. And lowercase?
Sides.
That's side lengths, yeah. So for instance, lowercase a, that's down here. That's the length of that side. All right, so then the first question we're asked here is, what side is the hypotenuse? First of all, is it an uppercase or a lowercase letter?
Lowercase.
It's got to be lowercase, yeah, because we're talking about a side, right? So then, now which one's the hypotenuse?
B.
It is B, yes. Now, if you weren't sure why that is, the hypotenuse, it has two different properties, and you could use either of these properties to identify it. It's the longest side always in a right triangle. So that's one way you could know, is you could look up there and you could say, oh, B is the longest, therefore that one has to be hypotenuse. The other way is that the hypotenuse is always the opposite from the right angle. So it's always the side that the right angle opens toward. That's got to be the hypotenuse. You can remember it either way. They both tell you the same side. All right, next up, we're looking for the side that's adjacent to angle A. Now, let's take a look up here at angle A. You notice it's formed by those two sides. Adjacent means next to, but it seems like both B and C are next to angle A. But only one of those is the adjacent. Which one? It's got to be C. Because, what was B again?
Hypotenuse.
B was the hypotenuse. So we already know that B is the hypotenuse, so B can't be the adjacent as well. It's got to be one or the other. So then C is the adjacent for angle A. Now, the part that if you wrap your head around it, these things get a lot easier. That last question, which side is adjacent to angle C? Notice that when we change which angle we're going from, we change which side is considered to be adjacent. So if I look at angle C here, it's got to be one of those two sides that's adjacent. Which one of those then is called the adjacent? A. because again, B was still the hypotenuse. So A was the side that was next to angle C, but wasn't the hypotenuse. Therefore, that's adjacent. All right. Now, if we know those, then we can proceed to actually writing these equations from a picture. So here's the first of those problems that we're going to be doing together. Go ahead and make a copy of that triangle that you see there. I'm actually going to reuse this same triangle with its labels here over the next few problems. So you can draw it once and have it represent for a number of different problems this way. And then once you've drawn the triangle, write down the information for this problem. All right, once you have that information written down, then we can start actually working on solving this out. Now, the first thing I want to do when doing one of these problems is to label a picture. Now, if I was doing this on my paper instead of up on the computer here, I would actually draw myself a little triangle just so I could have something to reference. Maybe make it look a little nicer than that. And I'd want to mark where the right angle is. And then I would label the parts that I want to be dealing with in this problem. So first of all, I'm told that the measure of angle C, by the way, that little M in front of the angle, that just means the measure of angle C. So the measure of angle C is 27. So I would then go over here and label that as being 27 degrees on my paper. Okay, and then side B is 65. So I'd then go over and label that side as being 65. And it's asking me to find A, so I would then label where A is. Now that's if I'm doing it on my paper, but of course I am doing it on the computer, so I'm going to make it the nice, pretty big drawing there. And so then this lets me visualize exactly which parts am I working with and which ones am I not working with, because then I don't have a whole bunch of extra information floating around in there. All right, now I can go to start solving it. So notice that I'm going from this angle, because that's the one I was told what it equals. I wanted to know at the start, what do I call each of the two sides that I'm working with? So let's start with the 65. What do we call the 65 side here? Is it opposite, adjacent, or hypotenuse? It is hypotenuse, yes. Remember, it is opposite the right angle. That's one way to know. Or you could also know because it's the longest side. Okay, what about side A there?
Adjacent.
It's either got to be adjacent or opposite. It is next to the angle, so yes, it is the adjacent for that. So we know in this problem that we're working with the hypotenuse and the adjacent. That tells us whether we are going to use sine, cosine, or tangent. I look through those three definitions, or I think back to Sohcahtoa, and I say which of those involves H and A. And it is cosine, yes. So that tells me I'm going to be doing cosine. So the first thing I write down on my paper in terms of the algebra work is cosine 27 degrees. So the interesting thing that you'll see as we do trigonometry is it's kind of a mix of geometry and algebra. Oftentimes we start with something that looks like geometry, but we end with something that looks like algebra. That's trigonometry at its core, really. All right, so I got cosine of 27 equals. Okay, now cosine equals adjacent over hypotenuse. I know that because of the definition of cosine. So then what cosine here equals is it's going to have to equal the adjacent over the hypotenuse. And I just plug in what each of those values are. So my adjacent here, that's my unknown. That is A. So I'm going to write A on top. And then my hypotenuse, that's 65. And so I write it then as A over 65. And then once we have that written down correctly, from here it's an algebra problem. I'm going to have to solve this to figure out what does A equal. And in order to do that, well, there's a couple different ways. One way is, in this particular one, you actually could multiply both sides by 65 if you feel comfortable with that. Or, think back to what we started class with today. You could write this as a proportion. Because once we write it like a proportion, then it's very familiar. This is something that we've done before. And if you're ever not sure what to do in math, make it look like something you've done before, and then you can do it. So now that it looks like something you're used to, go ahead and solve it. Figure out what A would equal in this problem. So we do solve it as we saw in the start of this lesson by cross multiplying. In this case then, a times 1 gives me a, of course, and then 65 times cosine of 27 is just 65 times cosine 27. That then is what you're calculating. We know that this is the point at which we plug it in the calculator because I have it as a equals. I already know what a is, so I don't need to go further. So I plug this in the calculator. The easiest way to plug it in and be super consistent is do cosine of 27, get that answer, and then multiply it by 65. You should be getting an answer here of about 57.92. Now, if we can do that one, all right, so when solving this problem, the first thing I want to do is I do want to make a drawing of this labeled triangle. And again, if I'm doing this on paper, I'm going to actually draw it out and draw a little triangle on my own and show what that's going to look like. Being on computer in this case, though, I can label a little bit more clearly by labeling on the big one, so I'm doing that here. I've labeled where angle A is, and that is 55 degrees. Side C, I've labeled that as 41, and then I've noted that I'm trying to find side B. This gives you a visual reference for being able to set up the problem from here. And so, the first thing I do now is I need to identify what do I call each of these sides. And again, notice this time I'm going from this angle, because that's the one I was given. We're always doing it relative to the angle we're working with in that problem. So, what do I call side B?
Hypotenuse.
It is the hypotenuse, yep. And what do we call the 41?
Adjacent.
It is the adjacent, yes. And I know it's the adjacent because it's next to that angle. All right, so once I know it's hypotenuse and adjacent, then I look back to my notes and I see, okay, which of the three, sine, cosine, and tangent, involves hypotenuse and adjacent?
Cosine.
And it is, yep, it's cosine. So I start by writing cosine of 55 degrees. Notice whenever I write cosine, the angle is always going inside of cosine. The angle is always what goes into cosine. Because cosine equals two side lengths that are over each other. And remember those two sides, the definition of cosine is adjacent over hypotenuse. So I'm plugging those values in. In this case, the adjacent is 41. So the 41 is going to go on top. My hypotenuse is the unknown b. So b goes on the bottom. So make sure you have that written down correctly now. And again, I'm getting that because I know I'm working with hypotenuse and adjacent. Cosine's the only one that does that. So that tells me the cosine part. And then cosine equals adjacent over hypotenuse. That's just from our notes. That's the definition of it. And so I write the adjacent on top and the hypotenuse on the bottom. Right. Now, we need to solve this. And while there are a couple different ways to look at it, the most familiar to you at the moment should be setting it up as a proportion and then solving it by cross multiplying. So go ahead and do that to figure out what this solution will look like. First step, cross multiply. In this problem, that gives us b times cosine of 55 degrees equals 41. Unfortunately, in this problem, it's not as easy as the last one, right? This is kind of like the second problem we did on the whole on today's lesson. I still got to get the b by itself, so that means I got to move the cosine over in this case. Because my whole goal is to get b equals. And so, since it's currently b times the cosine of 55, I'm going to divide by the cosine of 55. And so on the left side, that gets rid of the cosine of 55. That was our goal. On the right side, we're doing 41 divided by that cosine of 55. You're going to put that in your calculator as you see it there. So 41 divided by cosine of 55, do that calculation, and you should be getting about 71.48. This is the last problem we're doing. Go ahead and write this down on your paper now, and then we're going to step through this one piece by piece. All right, so in this case, I'm looking to figure out what the angle equals instead of a side length. The nice part is, though, that the same starting point that we used with the previous problems is still going to be the same place to start here. And that is, label a picture. Label the pieces that we know so that we can visualize what this is going to look like. Now, in this case, I'm actually looking for the measure of angle C. And so when I'm talking about opposite, adjacent, and hypotenuse, it's relative to angle C in this case. Yes, we don't know what it is, but since that's what I'm trying to find, that's the one that's relative to. All right, so then let's go ahead and start by saying what are these two sides called. So the 15 side. What's the 15 called? That is the hypotenuse, yes, because that is opposite the right angle. Notice I often will start by finding out where the hypotenuse is. If you do that first, often makes your life a little easier. All right, next up, the 13. What do we call the 13 side?
Adjacent.
That is the adjacent, yes.
Cosine.
And so, since it deals with hypotenuse and adjacent, yes, we know we're going to be dealing with cosine. Now, remember when I write cosine, I always want to put the angle in. I don't know what the angle is, so I'm just leaving it in with its name. I'm just calling it cosine of C. Equals. And that's going to equal adjacent over hypotenuse again, and I know it's adjacent over hypotenuse because that's the definition of cosine. Adjacent is 13, hypotenuse is 15, so it's 13/15. Little side note before we proceed, all the problems we've done today have been cosine focused. We are going to be getting into using sine and tangent as well, but we're just kind of starting with cosine so that we can kind of focus on one thing at a time. All right, so now that I have cosine of C equals 13/15, I need to figure out what that's going to equal. I need to be able to solve it. Well, this actually goes back to work that we did yesterday. How do we solve an equation that's cosine of an unknown? We take the inverse cosine of both sides. And remember, inverse cosine, that's that cosine to the power of -1. So I'm doing that to both sides of the equation. When I do that to the left side, that cancels out the cosine and just leaves me with C. That's the beauty of doing it. On the right side, I have the inverse cosine of 13/15. Now, some people look at this and they get kind of scared. That looks really high-tech and scary. But it's actually not so bad. 13/15, I could just as easily write a decimal in there, but it's a lot easier to just write 13/15 than some decimal that's going to end up being huge. So I'm actually trying to make my life a little easier by keeping it the fraction. But now that we are at the point where I have just C equals, that tells me I'm down to calculator time. So I'm going to calculate the inverse cosine of 13/15. And again, depending on what type of calculator you're using will change how you type it in. On a graphing calculator, pretty much you type it in as you see it. You do inverse cosine of 13 divided by 15. If you're doing this on a scientific calculator, do the 13 divided by 15 first. Get that number, and then do inverse cosine of that. If all goes well, you should be getting an answer of about 29.93 degrees.
How do you do it?
And notice it's degrees here. Anytime we do inverse cosine, it always gives us an angle measure, so it's going to be in degrees. Also, we could know that because we were trying to find the measure of angle C. So again, since it's going to be an angle, we got to include the degrees in there.